All right, so in this video, we're going to talk about increasing and decreasing functions as well as the first derivative test. Now, back in algebra, we had a pretty informal but intuitive way of understanding increasing and decreasing. I would generally describe it to my students as if you're walking along the curve from left to right and you're going up a hill, you're increasing, and if you're walking down a hill, you would be decreasing. And that's all well and good, but now we're at a point where we can formally define what increasing and decreasing actually mean. So in this first picture, again, we kind of see that it's increasing already. We would say that f is increasing on an open interval I if f of b is bigger f of a when a is less than b. Now let's talk about that. So increasing on an open interval I if this y value, f of b, is bigger than this y value, f of a, and you can see it is, but then the last condition that needs to be met is that a needs to be less than b. So a needs to be less than b, and on a traditional number line like this, we might say this is something like 2, but if we move to the right, this might be a 5, in which case a would be less than b. Okay? Now, the definition of decreasing is very similar. We would say f is decreasing on open interval I, but if now f of a is bigger f of b, and of course still when a is less than b. So this y value here, f of a, is now bigger this y value, f of b, once again provided on the number line a is less than b. And so again, even these formal definitions shouldn't be too bad to follow, but at least now we have a more general, more mathematical idea of what we mean when we say increasing and decreasing. Okay, so now that we have that out of the way, I'm going to go ahead and more or less just summarize this idea of the first derivative test. So we know from earlier discussions that f is increasing when f prime of x, f prime of x is positive, right? That's the slope being positive. If the slope is positive, then the tangent lines have to be have a positive slope. Therefore, your curve would be increasing or going up. We also know similarly that f is decreasing when that first derivative is less than 0. And many times we come up with these values, we come up with these points of interest, we come up with these critical values by taking f prime and setting it equal to 0. Now that's, again, the more general way of finding these critical values. We know they exist in other places and we'll continue to discuss that, but that's essentially where we're going in this first derivative test. And now, kind of going a little bit further, we can also see that when we have something that changes from increasing to decreasing, then you would be dealing with, right here, a maximum value. Similarly, when we have something that changes from decreasing to increasing, right here, we would have a minimum value. So again, you can see we would be increasing, and then right here at the top, that's this guy, right? That's where the slope of the tangent line is 0. That's where we have our horizontal tangent line. And so that's now where we transition into decreasing. Same thing here, we decrease, but a slope of our tangent line is 0, meaning we have a horizontal tangent line. And now we change back to increasing. So here in a little bit, when we start looking at some of these problems, the first derivative test is really just a culmination of ideas that we've already discussed. We're going to be able to figure out where the function is increasing and decreasing. We're also going to be able to figure out where we're going to have our maxes and mins. So I would encourage you, before moving on to the next example that I show, I would encourage you guys to review figure 4.21 on page 199. That kind of summarizes a little bit of my picture down here in a much more elegant way. And then also, guys, just as another reminder, I think the page 110, where they have those non-differentiable points drawn out for you, I think that's a good place to review as well as we get into these critical values where we're searching for the potential maxes and mins now.